it's my pleasure to pass to the first panel, a panel in which we will have some people joining us live, meaning directly via this platform to present and discuss. Some others, unfortunately, sent videos because they could not attend also due to the difference in time. But they will be represented by some delegates in the discussion that will follow. So as you can see already from the slide that I'm displaying, there's quite a few top prominent personalities that will now take the turn, in particular to give an introduction and an overview about initiatives from all across the globe. So we will have an international map of what's going on in terms of 6G at the end of this session. The first person that is now on the floor is Uwe Löwenstein from ITU-R. ITU, as you know, is the International Telecommunication Union. Uwe has a very strong and consolidated background in telco communication, and in particular, he has joined the United Nations in the ICT area in May 2020 as the counselor for the ITU-R study group in the Radio Communication Bureau. Without saying more, because I think the best presenter of himself is Uwe indeed, I would like to pass the floor to him. Uwe, are you there?
I'm here, yes. Thank you.
Welcome, good morning. So I will stop sharing my screen and give you the floor.
Okay, thank you. Yes, thank you for the kind introduction, and thank you to one6G for inviting us here to provide an insight on the topic for vision for IMT 2030 and beyond. My name is Uwe Löwenstein. I'm the study group 5 counselor for the ITU-R, and I would like to provide you an insight into what ITU is working on. For doing so, I will share my screen, which I should see you in a moment here. May I assume that you see my presentation now?
Yes, yes, it's fine.
Okay, perfectly. So what I would like to introduce to you today is to provide you some insights on the UN and the ITU-R. I will go along 2 slides explaining you the IMT family, the naming convention, and the IMT process. And then I will also be able to provide you a brief insight into the draft technology trends and the IMT vision for the systems 2030 and beyond. The ITU, the International Telecommunication Union, is one of 15 specialized organizations for information and communication technology responsible. The ITU has been founded in 1865, so we have passed already the 150th years anniversary a couple of years ago. And just to show you the span of what ITU-R is responsible, it's the allocation of the global radio spectrum for the wireless service. We coordinate the world satellites through the spectrum management and the orbit assignment. And we develop the technical standards that ensure networks to be available in underserved areas, but also in the cases of disaster and emergencies. The overall structure of the ITU is very complex. We see on the right-hand side, we have the telecommunication development sector. We have the telecommunication standardization sector, which is dealing with all the standardization activities in terms of the fixed. And we have the radio communication sector, which is dealing with the wireless services. And first to mention, as part of the responsibility of ITU-R, the radio communication sector, is the World Radio Communication Conference, which is happening all 3 to 4 years. The last time it happened in Sharm el-Sheikh, and the next time it will happen in 2023. And yeah, the most important outcome, I think a lot of the participants are aware of this, are the so-called radio regulations, where you have the assignments for the different services across the frequency bands between 9 kilohertz and 300 gigahertz. In parallel, we have the radio communications assembly, defining the structure of the work of I2R between two World Radio Conferences, currently the study period 2019 to 2023. And today I would like to focus on my responsibility as counselor of the study group 5, the terrestrial services. It is worth to mention that the application of the ITU radio regulations is being done across 3 regions. Some of the frequency assignments are harmonized all across the world. As we know, some of them are not harmonized all across the world, but in certain regions. We have overall 6 regional groups supporting the activities, and you can see the allocation here. Let's look into the IMT naming and conventions. We have the abbreviation, I think everyone is aware of, International Mobile Telecommunication, IMT. And already back in the year 2000, we have started with providing the standards for IMT 2000. And actually, we have now revision 15 of this ITU recommendation, which has been lately updated in October last year. This technology comprises 6 radio interface technologies. As you can see, you may remember there was a hard discussion who can become part of this IMT 2000 standards. Then next generation, I would call it, it's IMT Advanced. It was initially published in the year 2014. We have 2 radio interface standards covered by this technology. Then we have IMT 2020, which is being specified in ITU-RM 2150. The initial version has been published in February this year. And so far, there are 3 radio interface technologies incorporated. I will say so far, and as of today, 10th November, I will elaborate in another slide later. And we have the future systems here for beyond IMT 2020. They may become available around the timeframe 2030. And beside the official naming of ITU, the market has provided attributions to these generations of technologies, as I show here, 3G, 4G, 5G. We here at ITU, we prefer not to talk about these generations because this is very much affiliated with a lot of marketing approach. Important to understand and also to show you what we are doing towards IMT 2030 is the IMT process. I will not explain you each and single step here in this chart over spanning a time frame of 7 years, but just to explain you the principal approach of an IMT process. First, ITU will define a vision and a technology trends report so that we know what we are going to talk about. Then we will define the requirements and evaluation criteria, how to say and judge whether possible radio interface technology candidates fulfill the requirements with evaluation procedures. Then we have the evaluation phase, which is actually quite a long period, over 2 years. It stretched the last time. And at the end, after consensus buildings, we will have agreed on an IMT specification. IMT 2020 specification was agreed end of 2020. We have then the approval of study group 5, the superior organization, and we have the publication of the according ITUR recommendation. So what is in IMT 2020 radio interfaces? The scope is to identify and provide the detailed specifications, but also enable worldwide compatibility and international roaming and access the according services on an equal basis. The initial release includes 3 standards. 2 are coming from 3GPP. One is the non-standalone, the other one is the 5G standalone technology. We have a 5GI coming from India. And actually at the last meeting of Working Party 5D, sorry, it was agreed that a further technology, DOICT 5G SRIT, has successfully passed the requirements to become IMT 2020 family member. And this will be approved in the subsequent study group 5 meeting, which is scheduled for the 16th of December. So as I said, as of today, there are 3 radio interfaces, but we expect the next release to be published beginning of next year to contain the 4th radio interface standard. And if you look across the press, you have seen a couple of information already about the capabilities of this new standard and its possible differentiation from the existing ones. The final assessment not yet passed is the EUHT 5G by Newfront. They will probably come in one of the next releases. So what is the process for the systems beyond IMT 2020? We have a technology trend report. Already last year, 5D has requested the external organizations to provide input on that. And now we are dealing with the IMT vision, the new recommendation, let's say the core of IMT 2030. From the last meeting in June, 5D has sent out a liaison statement to the external organizations to provide input until the June 2020 latest. And as you can see, we have sent this liaison statement to around 50 external organizations asking for their input. And I like Nancy for her introductory words when she said it's important for the verticals to participate and to provide their views and expectations. We have then again the requirements evaluation criteria phase. We will do the evaluation consensus building, and around the time frame 2030, I would expect to have the new recommendation for the systems beyond IMT 2030, not to call them yet IMT 2030. Now let's look into the documents we are working currently. We have a draft new report on the technology trends. There are plenty of driving factors in the design of this IMT technology generation. Some of the buzzwords you know, of course, and for the time being, this is also not finalized, this report. We are working on it, and from each meeting to each meeting, the details on all these driving factors will be added and more extended. But what is interesting, we have some enhancement to the radio interface, co-frequency, co-time, full duplex. There might be new modulation schemes. Of course, we will go in the terahertz communication. There are even proposals to include visible light communication as part of the technology trends. But not only the radio interface shall be enhanced, but also the radio network performance and precision.
Du kannst dich, wie gesagt, mir ist egal. Ja.
Please mute.
Ist nicht an, also funktioniert nicht so gut.
Excuse me, please mute. The radio network performance and precision, we have new architectures to support these business models, but also the convergence of communication across the service, like harmonization and convergence with the satellite service are considered. We have draft contents, from my perspective, very important, also the consideration of artificial intelligence in the different ways. And technologies, more and more, you can read along them when you have the presentation available. For me, important is to also provide you a brief insight in the new vision for IMT 2030 and beyond. As I said, we have sent out the inviting circular letter to the external organization. The input can be provided until the meeting 41, which is happening in June next year. And we have a draft content. So this vision will contain the trends of IMT for 2030 and beyond, including the user application trends, but also studies on the technical feasibility of IMT in the bands above 100 gigahertz. And of course, we will also think about the technology trends and the spectrum implications. There will be chapters on evolution and the role, as well as the usage scenarios. And last but not least, the timeline is important, which will also be addressed in this new vision for IMT 2030. With that, I think to summarize is the best. Our work in ITU can be split in two parts. Between the two World Radio Conference, we study and agree on spectrum-related topics, which then become part of the radio regulations for the frequency and spectrum assignment all across the world. We could call this global regulation. But in parallel, and what we are focusing today also in this event here, it's not the WRC related topics, but IMT to drive the technology development. And so this would help us all to provide harmonized technology to the world as part of the United Nations organization. So we have the Future Technology Trends Report, the new vision, and I just can encourage you to contribute to the work of I2R, in particular I2R Working Party 5D, who is responsible for the IMT aspects. And with that, the future is bright. Share your ideas with I2R and be part of the IMT spearhead. I'd like to thank you for your attention. I'm available for any questions. And I think we have a panel later where we may discuss the one or other aspect as well. Thank you very much for your attention.
Thank you so much, Uwe. A lot of information, a very dense presentation that will possibly be made available also through the one6G web pages after the presentation. And now I just wanted to share my screen quickly, because I'm about to introduce the next speaker of this panel. That is Bernard Barani from the European Commission. Bernard is, as I'm sure many of you know, Deputy Head of Unit in the DG Connect. But he also he has been also playing a major role in the launch and development of the 5G public-private partnership, and also in the Industrial EC initiative that has led to the Smart Networks and Services joint undertaking that is being launched soon, as we will hear in more details from Bernard itself. Bernard, it's a pleasure to have you with us today. I will stop sharing my screen and give you the floor.
Pleasure is fully shared, Monique, and thanks a lot for your kind introduction. Can you hear me?
Yes, very well.
Excellent. So I try to share my slides then. Wow. And put it in full screen mode. Hopefully it works.
They are coming. Yes,
it seems
perfect.
It seems to work. So again, good morning or good afternoon, wherever you are. And I will try to give you a short overview of what we are planning in the European Commission in the context of beyond 5G and 6G type of systems. And first of all, one thing which has to be noted is that, of course, we are not the only one in the world. It seems that this beyond 5G, 6G type of activity is raising a lot of attention all over the world. And you can see here, not an exhaustive list, but a couple of major initiatives which are being taken all over the world to support research and development towards 6G, beyond 5G or 6G. And maybe the point to note here on this slide, compared to the situation we had with the 5G before, is that now we see that compared to the 5G times when 2011, 2012, we didn't have much presence from the US already in the early stages, where they came very strongly, but a little bit later. Now the US is also moving into the definition or the definition of what could be future type of system very early in this process. All the other nations, of course, had also had very early start in this business. Before. So on our side, you can see it at the bottom of the slide. We are in the context of launching an initiative called 6G Smart Network and Service Partnership, which we will support with a budget of 900 million euros. And it has to reflect, if you want, the number of policy drivers which are pushed or promoted by the European Commission, which is first, what we call these days strategic autonomy. That means our willingness in Europe to be much more present on the overall supply chain, not only connectivity, where we believe we are strong, but also other type of domains like microelectronics or cloud or IoT type of devices. We want also to contribute very much to the so-called Green Deal objectives. That means our ambition to be carbon neutral by 2050. And cybersecurity is also a very strong policy requirement, which is coming up from the European perspective. Worth noting there are a number of initiatives being started these days in Finland, Germany, France, Austria, also on 6G. And our intention is clearly to coordinate very much with these national initiatives, but also to coordinate and to liaise with the international initiatives which are launched elsewhere. So when we look at the 5G times, and now we look at where we are today, we see a number of factors of change which are kind of influencing the type of work we are preparing these days. First of all, and this was mentioned in the introduction by Nancy, the presence of vertical industries, which we didn't have at the early days of 5G, which we believe will be a very important factor to drive future systems, and they will, we believe, have a growing presence and influence into the overall process of definition of the new systems. This, of course, is related to the emergence of new business models beyond the classical MNOs, can be verticals, but can be also neutral host type of models, can be micro operators, as they are looking into it in Finland, for instance. So there are a number of completely new type of business models that have to be taken into account compared to the classical ones that we looked into in the past. Another important factor that we see coming up is this so-called softwareization or disaggregation of networks that we can see in moves towards Open RAN or virtual RAN. So this notion of having the capability of implementing network functions in software and running them from cloud platform is something very important that we believe will be an important driver in the context of future development of systems. Security, as I said, cybersecurity is important from a policy perspective, but how we put it, how we make it happen is something we have to look into it from a more broad perspective, I would say, because more and more what we can see is that systems are cutting across a much wider variety of domains, be they different business domains or technological domains. So the fact that systems can be implemented across different technological domains forces us or gives incentive to look into security, end-to-end security approaches that can be let's say seamless, cutting across domains that can go from the hyperscaler to an MNO to a vertical, which are completely different type of environments. As I said, we want to work on our autonomies, what we call strategic autonomy. That means that we look into this, let's say, new systems as a possibility for us to look into new generation of microelectronic components and new approaches to cloud and to edge cloud as well. And finally, an important driver that you see, which was mentioned in the presentation of ITU, the so-called human centricity, which is a possibility to contribute to the sustainable development goals that we see as very important type of drivers. So this all has an impact on how we are going to define our initiative, what kind of stakeholders we play with, what type of industrial landscape, and also what type of collaboration we initiate towards standardization and deployment eventually. So we started to look into the next generation of systems already 2 years ago, something like, 2.5 years ago, taking into account this kind of classical 10-year cycle that was visible in the ITU presentation. And we came up with, in the early days, let's say 6 types of focal points. Application level first, 2 types of application. On the right-hand side, as we said, drivers coming very much from the new use cases coming from the vertical industries that we believe will push requirements towards new classes of requirement beyond 5G. So lower latency, higher reliability, more machines to be connected. So this is the kind of evolutionary path, but also on the left-hand side, other type of applications, which are completely new classes of application that potentially will drive the definition of new systems such as holographic communication, Internet of Sense, which is this possibility of merging communication and sensing that we can see as a possibility offered by terahertz communication. Deterministic end-to-end is also one thing which is coming up as a driver, as a completely new type, for completely new type of applications. At the bottom of this chart, we can see the objectives which are related to sustainable development goals. On the left-hand side, ultra-low energy that we tend to look into from a dual perspective. So it's not only ultra-low energy from the platform itself, that means from the connectivity platform itself, but also from the perspective of the use cases which are underpinned by these technologies. So that means that we are trying to look into technological approaches that can optimize the energy efficiency of the connectivity platform, but also of the use case which is running on top of it. EMF is also something which we believe is very important in terms of acceptance of the technology, of the wireless technology by the citizen. And we can see that there are technologies that potentially could allow to have better control of EMF radiation in future wireless environments. So this is something where we want to put some emphasis. And other sustainable development goals such as affordability, accessibility, openness will be also present in our plan. But again, we are not putting it just for the sake of the political motto. It's just because we believe that behind these objectives, we can map technologies such as classical one being non-terrestrial networks for accessibility and wide range accessibility of the services. But you can think also of new ways of promoting accessibility through for instance, through the trend towards the softwareization of networks, which is supposed to lower the market entry barriers to make the technology more affordable and to bring economical capabilities to places and regions where previous type of technologies possibly were not affordable or were not economically viable. So in the middle, we have a focus on what is called by the constituency zero-touch networks. That means networks which are fully self-managed and autonomous with ultra-high security, trust, and privacy. So these are things which are important because we see that programmability and intelligence connectivity is something which is coming very strongly in the agenda of the various stakeholders which are looking into this in Europe. All over the place, you can see, and this was also in the ITU presentation, the emergence of artificial intelligence as a very important technological building block to achieve the objectives at various levels of the new platforms which are going to be looked at. So we didn't stay idle. Already early January this year, we launched a bunch of 9 exploratory projects on 6G. So the one that you can see on the top left corner of this chart, XAX, is our so-called flagship project, where we have a large number of European key players looking into technologies and vision for future systems beyond 5G or 6G. This flagship project is complemented by 8 projects looking into elementary or individual bits and pieces of technologies. And altogether, these projects have delivered a kind of European vision for the 6G network ecosystem that was in June this year. And this vision basically combines or bring together three different worlds, the so-called physical world, the digital worlds, and the human world. And this vision is based on the idea that if we manage to have a massive digital representation of the surrounding environment, and this is something that comes from the digital twin type of experience that we see developing in industry, if we have a massive digitization of the surrounding environment, which is connected to the intelligence, to the knowledge of what is happening in this environment, we can manage to have a wide-ranging or a large-scale representation of the surrounding environments of a particular type. We can think of a smart city, for instance. And with this awareness, which is called the connected intelligence of all what's happening in this environment, we can have strong actions, or we can take actions in the physical world to correct or to influence the way things are happening in the real world. So these kind of notions you find at the URLs which are indicated at the bottom of this chart. I will go fast. Unfortunately, I don't have much time. So I will not expand on this slide too much, but just to say that on the vision, we have identified a number of key requirements for future systems, a number of key technologies, and how these technologies coincide or support the new type of KPIs which are being investigated for this type of new systems. These KPIs is still work in progress, of course. There is no commonly agreed position what they should be, but there are a number of ideas floating around. What is important to note is that in our case, we are not only working on KPIs, but also on what we call KVIs, key value indicators. And these key value indicators are, if you want, quantified indicators stating how far you reach the sustainable development goals or how far you can reach a societal goal. So this is an important dimension which we believe should be brought into the overall landscape of requirements and indicators. So to progress on that, we are on the verge of launching this partnership called Smart Networks and Services Joint Undertaking. As you can see, this will complement or will continue the set of 9 projects we have launched this year. This is supported by a number of industry associations, 5G-IA, which is the key association, which has now been relabeled the 6G Infrastructure Association. So this is the connectivity, let's say, landscape, but we have also strong support from industry association working in the IoT domain and also in the cloud domain in such a way that we can reconstruct this end-to-end value chain perspective beyond connectivity that I was mentioning at the beginning of this speech. So in terms of timeline, we are about, as I said, to launch this initiative. We expect to have a call for proposal early next year. 240 million euro will be our first call for proposals in that particular domain. The initiative itself will expand over basically 7 years, which is the time frame for the research program, the EU Horizon Europe research program that is supported by the Commission. And here you see how this is tentatively mapping the overall timeline of 6G or beyond 5G deployment as it is seen by the main actors at this moment in time. We intend in our first call to already initiate research and innovation, but also to move towards proof of concept and test platforms, because we want to develop as early as possible research platforms, pan-European test platforms, which will have a pan-European scale in such a way that user can very early in the process test their use case and validate the technology in the context of their particular type of requirements. So with this, I thank you very much for your attention. On this slide, you have a few URLs where you can find additional information. And again, thanks a lot for your attention, and very happy to provide further information if you want to have any. Thanks a lot.
Thank you very much, Bernard. Thank you. I'm gonna now share the screen once again. I hope you can see it. To introduce a speaker that unfortunately cannot be with us. So we have a video. It's Zhiqin Wang, that is the current president, the vice president of the China Academy of Information and Communication Technology. She's also the vice director of the Wireless and Mobile Technical Committee, China Institute of Communication, and the chair of the Wireless Technical Committee at China Communication Standardization Association. So she will provide us an overview from the Chinese perspective on a number of ongoing activities. Now I give the floor to the technical directors behind the events for them to so here we go.
Hello everyone, I'm Wang Zhiqin, the chair of IMT 2030 Promotion Group. I would like to give an introduction on the work progress of IMT 2030 PG in China. IMT 2030 PG was founded in June year 2019. It includes expert committee and 6 working groups. Currently, we have a working group for requirement, wireless technology, and network technology, spectrum, standards, and international cooperation. This year, we newly established Economy and Society Working Group. Now, IMT 2030 PG have over 30 members. We are open to members around the world. The requirement working group start with the overall motivation and driving forces for exploring the application and services of 6G. Based on the global 5G development experiments, it summarized 6G fundamental use cases, user and application trends, usage scenarios, and gradually built the key technology performance identifier system. In June this year, IMT 2030 PG released a white paper on 6G vision and candidate technologies. This white paper summarized the current study results and especially proposed 6G vision to realize an intelligent connection of everything, digital twin society. 6G will transfer the Internet of Things to intelligent connections of everything. Now we come to the wireless technologies. Currently, we have 11 task groups in 4 categories, including enhanced physical layer technologies, emerging technology with convergence and integration, new physical transmission dimension, and new spectrum-driven technologies. So far, there are 5 technical reports published from wireless technology working group, covering 5 technical research directions. With the emergence of new materials and technologies, the scale of the antenna array will be further expanded to support new scenarios and services. The research work on new application scenarios, especially new array structures and deployment methods, combined with new materials, are further combined with AI and machine learning, become popular research topic. For telephone communication, we need to analyze new application scenarios as well as to do some basic research on channel model. In terms of key technology, it's also necessary to carry out fundamental investigation on the basic physical layer technologies and consider the combination with sensing, AI, and other technologies. The realization of a commercialization of the telephones will largely depend on the maturity of devices and industrials, as well as the discovery of application scenarios. The integration of sensing and communication is a new research direction. The integration level of sensing and communication will be evolved from function coexist to joint waveform and signal design, and finally, networks materializing to realize deep information and network collaboration. For the key technologies, the task group is carrying out study on basic serial, air interface, architecture, and device. From the perspective of the 6G-oriented research, we may have an opportunity to build a novel wireless AI network architecture and air interface protocol to realize a new end-to-end network with native AI. Specific research will involve new AI, effective efficiency AI machine learning algorithms, basic serial of computing, storage, and communication costs and performance limitation. Reconfigurable intelligence service controls signal propagation direction, suppressions, interference, and enhance the signal. It can be explored in a non-idle transmission scenarios, such as unlost condition and seal edge error. Currently, we have conducting research on basic theories, modeling technical solutions, and related algorithms. This will also invite many changes and innovations in new materials, radio architecture, and interface design. Now we come to the work in Network Technology Working Group. This group established 2+6 technical research direction. 2 is the network architecture and network security. 6 is the 6 technical directions, including deterministic network, computing power network, information central network, digital twin network, intelligent network, and integration of terrestrial and non-terrestrial network. In September this year, Network Technology Working Group published a white paper entitled 6G Network Architecture Vision and Key Technology Outlook. The white paper proposed compatibility and simplicity as the 2 principles in network architecture design, with 4 highlighted characteristics. It also proposed 6 potential compatibility technologies and 6 potential architecture technology for the further consideration. The Spectrum Working Group has the tasks on 6G spectrum requirement study and global spectrum policies. Their work also includes 6G spectrum plan on the ITU framework, as well as to explore new frontier for 6G spectrum. Some spectrum-related technologies, such as spectrum sharing, also be included. Standards and the International Cooperation Working Group is actively built on communication cooperation mechanism with global organizations. They are also responsible for the output from IMT 2030 PG to international standard organizations. To promote the healthy development of global 6G, I suggest first is the successful commercial deployment of 5G will lay a solid foundation for 6G. It should coordinate development of 5G commercialization and 6G research. Second, the in-depth convergence of data, operation, information, and communication technology will be catalytic for the innovation of next-G network. Mobile communications have been successful on the basis of global cooperation. We hope that 6G will be continued to uphold the development concept of openness, sharing, and win-win cooperation. Let's work together to create a healthy development environment for 6G. Thank you very much.
Thank you very much for this video from Zhiqin Wang. Now we go on with the next speaker. I hope now you can see my screen, because I would like to introduce Kai Börner from VDIT. Actually, in September 2015, he joined VD Innovation and Technique, and in particular, a project management, a senior consultant responsible for the management of research and innovation programs for the BMBF in the area of future communication systems, including, of course, 6G. So we will discover more from Kai in a second. Kai, can you hear me?
Yes, I can. Thank you.
Great. So I will stop sharing and pass you the floor.
Yeah, so just give me a second. I hope it works now.
Yes, we can hear you and
That's
see
perfect.
your slides.
Yeah, so thank you for your kind introduction, and also thanks to Mr. Barani, who introduced, let's say, the European view and, let's say, gave some hints to the German 6G initiative. I would like to present you, let's say, what's going on in Germany and what's about in the German 6G research and innovation initiative. And I hope you will find it educating. So just first of all, where the funding is originated from, in Germany, there was a economic stimulus package, and we were lucky that this money will spend on research on 6G and other future communication technologies, and in specific, the German Federal Ministry of Education and Research, well, is in the lead position here to do so. But other ministries are also having some research activities on 5G and Open RAN, just to let you know. Just these are the overall goals of the German 6G initiative, well, which might be similar, let's say, to the European strategic autonomy. Also, Germany likes to increase the technological sovereignty and decrease dependencies in supply chains. Also, another aim is to establish a strong research foundation and a technological ecosystem for 6G technologies. And also, having these tools at hand, there should be decisive shaping of the 6G standard and in its applications from the German side. Also, another aim is to increase the production of key 6G components in Germany and in the EU, making Germany and the EU a leading supplier of network equipment. So now I will give you an overview about the calls which are so far planned. This year already, the project AINet started in February, which originated from the Celtic Next initiative. And this is a research cooperation on the European scale, dealing about, let's say, high performance services for at the network edge, and to make them managed automatically. And also, which shall be the research foundation of the 6G initiative. These are the 6G research hubs and the 6G platform. Just to let you know what this is about, these research hubs, these are research institutes and universities, which should be making some research on the ground scale for technologies for 6G, but they should also, let's say, provide cooperation opportunities for the industry or small and medium enterprises. And let's say at the end of their duration, they should already come up with some test beds and stuff, which might be a little earlier than, let's say, earlier Mr. Barani explained. So therefore, providing the opportunity, especially for verticals, to test their technologies in these test beds. And which leads me to the next big milestone in the initiative, the 6G industry projects, where the call is right now open for submission, and it will end in December. And we expect to have there many projects covering also the topics which were already mentioned before. And all let's say key stakeholders, let's say in this field of area, should be involved there, like let's say network operators or the verticals, and also the companies which provide the technology. And also this call should be accompanied by another topic, let's say, because we see that resiliency in digital systems and communication systems is an important topic, because, say, many applications will be based on network functionality, and it's very important that they work all the time and suffice all the needs by the application. And also another call will be the cluster competition, where, let's say, not just 6G research will be made, but let's say where the ecosystem is supported, like providing software and hardware and stuff, all things needed, let's say, later on when 6G is commercialized, that let's say we have an ecosystem ready to provide or to transform the results made in research to transfer them into the market. So I think the main expected areas of research are well aligned with the prior presentations, like in spectrum or joint communication, sensing, network and computation, as well as non-public networks for industrial scenarios, which is very important, let's say, for the German industry, and I think also for every other industry in the world. And I think what was not mentioned before, that we also have post-quantum security, and also we think that in this area also quantum entanglement could be a key factor for secure 6G communication. And there was some very fundamental research made in the recent years in Germany, and we hope that these results can provide some tools for secure 6G communication. And as already mentioned, flexible and resilient networks, also a very important topic. And also say that the networking is aimed for human-machine interfaces and for extended reality. So, and also, let's say it's not just a national initiative. Of course, 6G will hopefully be an international standard. So a strong cooperation with the European flagship project HexaX and all other following projects of the Smart Networks and Services Initiative will be, is planned. And also, Germany likes to establish a cooperation with politically like-minded countries and their national 6G projects. And well, overall, the aim is to harmonize the global 6G vision, and also that Germany can deliver strong contributions to the 6G vision, define requirement as needed by key industry branches, and to prepare the 6G standardization, which will be somewhat more in the future. So just, let's say, to put it somehow on the timeline of the international scale, here you see, let's say, that we have the 6G platform, which is kind of an interface, let's say, to the international scale, and also is kind of bundling all activities in Germany. And yeah, for instance, let's say, architecture questions, and you see that there are the research hubs which have a duration of 4 years, and since the call will be closing for the industry projects in December, we think that they might start, let's say, in the second half of 2022, or maybe earliest, let's say, in the Q2 of 22, and also, let's say, all projects related to the resiliency of digital systems, they will start maybe half a year later. And say all these projects, they should, let's say, harmonize their results, let's say, internationally, and let's say some cooperations with countries like the USA, China, or South Korea, or Japan is intended there, and let's see how that will turn out. Yeah, just to give you a summary of what I was talking about, let's say the main goal, just to stress it again, is to strengthen the technological sovereignty in Germany and the EU. And let's say the real projects, they started in August this year, which are covering the main 6G targets. This is a research foundation, as I told you. These were the 6G research hubs and the 6G platform. And also the other calls are right at hand. They start right now. And yeah, Germany is open to cooperation. And yeah, we hope that there will be a strong ecosystem in the future in Germany. And I think this is all I have to say about the German initiative, and I hope it gave you some information. And maybe if you have some questions later on, I think you can question me later in the panel discussion. Thank you for your attention.
Thank you very much. Thank you, Kai. Now it's my pleasure to share the screen again. So just a brief introduction to our next speaker, that is David Lister from NG and MN Vodafone. So David is leading research on future disruptive technologies within the Vodafone Group as senior R&D manager. He has consolidated experience spanning across the introduction of 3G, 4G, and 5G. And he's currently responsible for all aspects of 6G research in the Vodafone Group and in the so-called and is the co-lead of the next generation mobile networks, this NGMN. That is a strategic program on 6G that has recently published its 6G vision. I'm sure that we will hear more about this vision in the presentation of David, and I'm happy to leave the floor to.
So thank you, Monique, for those kind words of introduction. I hope you can hear me okay.
Perfect.
Fantastic. Let me just share my screen and put it onto presentation mode.
Great. We can see your screen. Yes, perfect.
So thank you, and thank you again for the introduction. So good morning, good afternoon, good evening, wherever you are. And thank you again for inviting me to this, I think, first summit of one6G, exciting times. So my name is David Lister. As you said in the introduction, I'm broadly responsible for the 6G research in Vodafone Group. And I'm also the co-lead of the strategic 6G project in NGMN, which is the Next Generation Mobile Networks Alliance. So today I'm delighted to be talking on behalf of NGMN, and I'll be giving an update of their activities, a bit of an introduction, and explaining how they plan to support the industry in developing a 6G vision and its requirements. So a quick introduction. So NGMN Alliance is an international forum. It was founded by mobile network operators with representation from around the world. So it's got a bit of a different history compared to some of the other organizations we've already heard of this morning. And its goal is to ensure that the next generation network infrastructure, the service platforms and devices, all meet the requirements of both operators and ultimately satisfy end user demands and expectations, and those of our customers. And as well as the network operators, the alliance is composed of a very broad, diverse set of partners from across industry and academia, and it represents all parts of the value chain and the technology cycle. So you'll see there are many technology and company logos that you can recognize, ranging from the handset providers through to infrastructure vendors and some of the large internet technology companies. So I'd just like to go into a little bit of detail on the 3 strategic projects, which reflects the way that the NGMN Alliance is structured, and these are the priorities for the group overall. And each of these projects are interconnected. The 3 big ones: disaggregation, green networks and sustainability and sustainable networks, and then 6G. And the first 2, disaggregation and green networks, they commenced with 5G networks in mind, but given that the outcome from these activities will influence networks well into the 2030s when they're deployed, they're really generation agnostic, and their outcomes will therefore transcend both 5G and 6G networks. The first project, disaggregation, this reflects a major trend in the industry towards much more open, virtualized, cloud-based networks. There are really 2 sides to this. There's vertical disaggregation, where network functions become decoupled from the software and the hardware, and this enables both the hardware and software to then be developed separately. And there's also horizontal disaggregation, where more established network functions are decomposed into granular elements, and then new interfaces are designed and specified. And disaggregation is attractive because it offers opportunity, it offers innovation, agility, flexibility, all these good things. But on the other side, it does create systems that could potentially be much more complex. The number of interfaces increase, and the role of the system integrator changes, and mobile operators will need to take responsibility for some of those aspects. So this project aims to support this end-to-end model. And the second strategic project is green networks and sustainability. And as can be expected, this project is of global concern, not just for our industry, but for others as well, gaining increasing interest from many companies. And it's also an increasingly important aspect of supply chain decisions by mobile operators, who are increasingly using energy and sustainability metrics in their procurement and vendor selection processes. And the third project, which of course I'll be focusing on from now, is 6G. And this is exploring how networks in the 2030s may need to evolve to reflect the new technology capabilities and deliver the use cases that operators may consider supporting. Now, we recognize we're at a relatively early stage of 5G deployment. There's a lot of learning to be established, and 5G's got a very well-established route moving forward through this decade when it will be enhanced and deployed. And this project will be exploring what additional features therefore need to be developed on top of this infrastructure from 5G and its maturity. So just breaking this down into a little bit more. So each of the projects are broken down into a set of activities for disaggregation. This includes the end-to-end operating model, automation, cloud-native networks. For green future networks, this will deliver output related to end-to-end sustainability, the eco-design of products, network efficiency, and smart metering, which is how do we actually monitor and measure energy consumption of individual components in the system. If we can't measure it, we can't improve the efficiency. The 6G project is broken down into three parts. It's completed its first deliverable related to drivers and vision, and this will be followed by use cases and then onto requirements. And I'll go into a bit more detail in the following slides. And in addition to these three strategic projects, there are a number of tasks related to ensuring that 5G evolution meets the needs of the industry. And these contributions support the work of the strategic projects. So the 6G project is co-led by three companies, it's China Mobile, Vodafone, and US Cellular. And its scope at this stage is identifying the important drivers and vision, and collecting, reviewing, and analyzing use cases. And then at a later stage, we'll be focusing on the requirements. Now, you've already heard some excellent presentations from different organizations. So the context of NGMN, we are just one of several large international global organizations helping to shape next generation networks. And I think what maybe is a bit different in NGMN is that we're a global voice for mobile operators and industry more broadly. Previously in NGMN, prior to 4G and prior to 5G, it created and published various white papers reflecting the views across industry. And we think that's resulted in significant contributions that helped to shape requirements and ultimately helped to shape standardization and globalization and harmonization. And we're taking a similar approach towards setting these requirements for 6G. To date, the project has already produced a paper on drivers and vision. It's not a technology paper, it just sets out some high-level principles that help to guide 6G development. And the next stage is well underway, in which NGMN has sought inputs from across industry on potential use cases that may support and set the requirements for 6G. So we also have a timeline with some project milestones. As I mentioned, we're currently progressing with the use case activity, Q4 21. That will lead to publication early next year, and this will be followed then by our guidance on 6G requirements working through 2023. So I hope we can contribute to the ITUR and this IMT 2030 6G visions as well. I just want to pull out a couple of points, really from the first 6G white paper that we published earlier in the year. It's not a technology paper, it's just a set of high-level aspirations and principles. And broadly, they can be summarized into 3 categories. Firstly, we put societal and environmental benefits high on the list. And this reflects the contribution that connectivity can make to meeting those UN Sustainable Development Goals that Mr. Barani mentioned, and the services that are delivered, and also reflecting the need to ensure that the carbon and environmental footprint of networks is minimized. And this is becoming increasingly important as we move forward. Secondly, the outcome from future networks should create new value. They can either reach that value through expanding the reach of existing services or create new differentiated services. But that's the aspiration, that we're creating new value and new customer benefit. And finally, future networks must be able to manage and ideally automate any new or additional complexity to ensure that those services are able to be delivered in a cost-effective and affordable way. So this leads on to the current status of the activity, which is the use case work. You've heard that other groups have done similar types of activities where they've identified use cases. We're doing something similar, but what we are also doing, maybe it's a little bit different, is we're grouping these down into a smaller generic set that we call families, and they're being analysed in a few different ways. So firstly, the project team will assess how these use case families will align, or do they align with the drivers and the vision that we discussed previously, those 3 high-level principles. And secondly, the team will assess them to understand what, if any, differentiation there is relative to the capabilities provided from advanced 5G networks, and also to understand both the applicability and the feasibility of each category of use cases. So that really the purpose here is to understand how the networks can evolve to support these needs, whether they are applicable for wide area mobile networks, or maybe these use cases and maybe the features and the technologies are more bespoke for individual needs. So we need to understand where this all fits together in terms of a future network evolution. And of course, it needs to be understood as well whether some of these technologies are practically feasible. When considering real world network constraints, which are constrained by things like radio spectrum, bandwidth, infrastructure assets, energy, power, EMF, radiation limits, and then onto affordability. So all these things need to come together in a way in which networks can ultimately evolve, deliver value, and do it in an affordable, green, and sustainable way. So final slide, just to sum up really, we are very fortunate at NGMN. We've got a very large active membership, a large number of industry contributors across a large number of different sectors. And hopefully we can provide some thought leadership with supports from our partners and feed into some of these other groups as well that you've heard previously. We meet virtually bi-weekly to progress activities of the project, and of course, we always welcome new members. So if you have any other questions, of course, I'll be on the panel, and the contact for the NGMN office is also on the slides. So thank you very much, and I think I'll stop sharing now. Back to Monique.
Thank you very much, David. Indeed, I was gonna say probably there are gonna be questions on how to possibly join and contribute to this initiative. You anticipated the contact person for this. So now, actually, I'm very happy that instead of having a video, we have Luciano Mendes with us live from Inatel. Luciano is in Brazil, so probably very early or very late in the night, I guess very early in the morning. Professor Mendes is with the National Institute of Telecommunication in Brazil, and is the technical coordinator of the Brazil 6G project. And that is an initiative to co-create an ecosystem for 6G networks in Brazil. Now it's my pleasure to give him the floor and let him go on with his presentation. Luciano, can you hear me?
Yes, I can hear you.
Okay, great. We can see you, not yet your slides.
Hopefully you can see now.
Something is coming. Yes, perfect.
Wonderful.
Beautiful.
So,
thank you, Luciano.
Thank you very much for the introduction, and thank you for the opportunity to show a little bit about the Brazil 6G project in the 16G Summit. So, as Monique said, my name is Luciano Mendes. I'm professor at the National Institute of Telecommunication Brazil, and I'm coordinating the Brazil 6G project. And my goal here today is just to share a little bit of the initiatives that we are developing here towards creating an ecosystem for 6G in Brazil. So you also see that the scenarios for 5G are heavily based on enhancing the access to more information, so increasing the data rates with the enhanced mobile broadband connectivity, also providing connectivity for more devices with the massive machine type communication, and you of course have the ultra reliable low latency communication. So we'll all see these three scenarios, and you'll know how they integrate together to create the 5G environment. And when you see the background of those scenarios, the technology that sustain them, it's really based on new techniques that have been developed to operate in a dense area in terms of population. So you see the massive MIMO with very large antennas array that operates in higher frequency, which does not propagate quite well in long distance. That is organized in the small cells, and they need to apply a cooperation point to deal with the interference. So all those technologies are built in the background for the scenarios for 5G networks. And the challenge that we have here is that those solutions are not really appropriate for remote areas operation. So there is a missing scenario in 5G, which is providing high throughput, low latency, and high capacity networks in remote areas. And that's very important for the Brazil society, because as you know, Brazil is one of the largest food producers in the world. Agribusiness in Brazil is very strong. It takes a huge part of our GDP, and technology up to now it's behind in terms of providing and supporting these kind of verticals. We have seen lately some efforts to include remote areas connectivity in 5G. We expect that release 17 will have some sort of connectivity for remote areas based on the 5G new radio light, but it's unlikely that all the requirements of these verticals will be supported by this approach. It's important to state that remote areas connectivity and rural areas connectivity does not demand some megabits per second. It's not some connectivity that's needed there. It's really high throughput, low latency for several applications to put the agribusiness in a new level of production. So why 6G is being seen in Brazil as a solution for those problems, right? So first of all, Brazil is a continental-sized country. It has a huge area to be covered. There are a lot of areas that has no connectivity at all, and that's a huge problem for the Brazilian society as a whole, right? So there are people that are living in areas that has no telecommunication infrastructure. Nowadays, around 28% of the Brazilian population are not connected to the internet. It's hopefully 6 million people that are not connected today. So it's a large number of people that can be integrated to the digital area if you provide the proper connectivity. And as I mentioned, the agribusiness is really a huge vertical in Brazil, which needs to be supported by the technology and have all the requirement support for the next generation. So it's those two motivations that are the main ones that are driving the development of 6G. And now we are trying to be a more active player in the definition of the requirements for the future networks. So it's very important to state here the importance of this one6G association, because it's opening the opportunity for other countries that is not located in US, in Europe or in Asia, to also provide inputs, to also contribute with the definition of the future mobile networks. So the one6G association is really a gateway for us to provide contributions for what is coming in the future. So how you can use those information, right? So how can you use this new network to fulfill the problems that you have here in terms of connectivity in Brazil? First of all, as we have seen in the previous presentation, 6G network is not going to be only communication, but also be integrating sensing, imaging, positioning into the network. So the network itself will provide several new features that can be exploited in new user cases, can be exploited in new applications, and those applications are really pointing to solutions to problems that we have here in several scenarios. Right? So I will talk a little bit about how Brazil is planning to use this future network, but it's important to highlight here that the main challenge in all those scenarios is that instead of just providing high throughput or low latency or connectivity to several devices, those conflicting and contrasting requirements, they need to be provided at the same time for the future networks. So it's not more high throughput or low latency. You need high throughput and low latency in the same network, which means that you're going to need to use several new radio access networks. You need to integrate much more networks into the 6G environment, and that's going to be the biggest challenge in terms of radio access network for 6G. So the first scenario here is the extreme world coverage. The idea in these scenarios is to provide broadband connectivity in any point of the Earth's surface, in the sea, in the air, or anywhere in the globe. You can have some megabits per second to your smartphone. The connection should be seamless, so they should be completely transparent to the users. And of course, satellite networks need to be fully integrated to the terrestrial network to provide this kind of connectivity. One point that's important to Brazil, besides the broadband connectivity that might integrate several people into the internet, is also the possibility to deploy sensors in very remote areas and provide the environmental monitoring. This is huge to Brazil because you have Amazon forests that need to be monitored all the time. You have several wildfires in the recent years in those areas. So detecting those fires and be able to act promptly can save several square kilometers of jungle, and they also can provide infrastructure to the government to monitor what's happening in those areas. Border control is another example, and also monitoring the water is quite important. As you know, Brazil has a huge hydraulic power plant, so most of our energy came from rivers and from hydroelectric powers. So monitoring the water is quite important for us. As I mentioned before, agribusiness is huge in Brazil. We provide several tons of products from agribusiness in terms of animal protein and also from plants. Soya beans, for example, it's a huge production here in Brazil, and also cattle and livestock is quite important. But when you look to the charts regarding production versus the occupied area for agribusiness, you can see that the production is growing very, very related with the extended areas that is being exploited for those productions, which means that in order to produce more, you need to use more area to provide this higher production. And of course, that's put a lot of pressure in the environment. that cannot keep going on this way. We need to increase the productivity per square kilometer, and technology has a huge role in this performance. Of course, we need to provide connectivity for use the technology. Most of the machinery used today in the farms, they have some interface to be connected, but unfortunately, you don't have the network there to support it. So that needs to change. Also, you are seeing that with the pandemic, you were forced to use this kind of remote interactions based on video and based on audio. And of course, that's not enough. Brazil are very warm people. They like to touch each other. They like to be in touch. So you're seeing that it's this kind of interaction that you have today, it's not enough. The humans have evolved to use all the 5 senses in communication. So also you need to include another layer of connectivity in terms of remote interaction. So tactile information is very important. So you're looking also for that, how you can provide tactile information over the network in terms of apt communications. So that's a very interesting user case here in Brazil as well. Not only for humans communication, but also for controlling machinery in remote areas. Like mining is also important business in Brazil. So be able to control machinery and have the tactile feedback in the remote location, it's quite important as well. Invisible security zones, they are being proposed mainly for places like airplanes and boarding areas. So the main idea here is to use the sensing capabilities of the 6G network to allow people to enter in the gates and also at the same time verify if there is some threat coming from those persons, like possession of drugs or possession of explosives, or if they have some guns. So the idea is to clean the checkpoints, make it more human again. So ease the way that we can get into the airplanes, but without the hassle of going through the checkpoints and have the X-rays and that very stressful experience that we all have. And in Brazil, you are looking to this technology also to apply it in public areas to help with the public security. So that's one of the biggest challenges here in Brazil. Safety and the crime combat is very important. And we are aiming to use the same technology also in public areas to prevent crimes and help the authorities to enforce the law. So Brazil 6G project is an initiative that started early this year. And the idea is to get together the main research institutes and universities in Brazil. So Inatel is leading from the technical point of view. Also, you have other institutes here and the other universities that are building together this view of the 6G network for the Brazilian society. So the main goals of the project is to provide the vision, scenarios, and the requirements that are fulfilling the needs of the Brazilian society. So understand what you need from this network, and then provide the technical requirements for the network to fulfill those visions. We are also working on the state of the art in terms of the enabling technology, and we are trying to contribute with other standardization efforts. So in order to achieve those goals, you have 6 work groups that are dealing with different problems, different issues in terms of user cases requirements. So you have one report already read in terms of what we need from the networks and what are the requirements that you expect to receive from it. We are also looking for artificial intelligence and how it can be used in the network as a whole, not only on the layers of the network, but also how the network can provide artificial intelligence services. How 6G can also be a platform for artificial intelligence solutions for the end users. Of course, you're looking at the sensing, imaging, position, and that's very important for several user cases. as I mentioned before. We are also looking for the physical layer and MAC layer protocols, what you can change and what you need to evolve in order to fulfill the requirements that you are needing. You have one group here focused on the antenna, RF and optical communication, how those can be integrated to increase capacity and also provide connectivity in remote areas at the same time. And the last group is working with the architecture for 6G networks with some disruptive approach to support the new services. So our next steps, the first one, we are building now a platform for proof of concept demonstration. And this platform will fully be based on artificial intelligence. So it must be able to run and train and provide artificial intelligence services for the end user. We are interacting with other research institutes around the globe to exchange the experience and also try to collaborate more. We are transferring this technology to the industry, so we have already some partners that are not willing to wait 6G to become true, to use this technology, so they are trying to use these initiatives in proprietary solutions. We are also training engineers, masters, and doctors in 6G communication, so they can be ready to deploy, operate the network when it can. And also we are contributing with the government and the agencies for regulations. So that's what I have to show to you today. Thank you very much. And I will be able to answer some questions later on the panel.
Thank you very much for your presentation, Luciano, very dense and very enlightening. Now I would like to share quickly my screen to introduce the next speaker that we have with us. Actually, it's the last speaker of this session about international views on 6G, followed then by a panel in which all the speakers will be invited. So Takehiro Nakamura is Vice President and General Manager of the 6G laboratories in NTT Docomo. Mr. Nakamura has been engaged in R&D and standardization activities across various technologies and fields, and he has been actively engaged also in many 5G initiatives in Japan and globally. It's my pleasure now to pass the floor to him, and we can see you, we can hear you. Takehiro, I will stop sharing my screen. You can go on sharing yours, so we see whether.
I will share my screen. I hope it works.
Something, it's coming. So, perfect.
Yep. Okay.
Yes, indeed, perfect. Thank you very much. The floor is yours.
Okay, thank you very much for your kind introduction and inviting me to this great event. And today I'd like to explain our views on the 6G and also not only my company's activities, but also the Japanese activities after that. And we are working for the 6G beyond 5G aspect as a name of the 5G evolution and the 6G. So I would like to explain the high-level concept shortly. Okay, so requirements for the 6G wireless technologies. Maybe the previous speakers, many of the speakers provided the similar requirements, and but we showed we listed 6 requirements, as you can see, and yeah, many of them should be a further extension of the 5G performance, such as the high data rate capacity, left top, and right top, extreme low latency and high reliability, massive connectivity. But left second, extreme coverage. This will be a very important for the 6G era. Especially, we should provide excellent coverage not only on the terrestrial area, but also the sea, sky, even for space, we think. And also now extreme low energy and cost. This is a very, very more important compared with the past generation systems, considering the SDGs or ESG. So we need to address more on the extreme low energy and cost. And the technical components for the 5G version and 6G. We listed the 8 topics, and many of them should be the further enhancement of the 5G technologies, and some of them should be very new. And I think that it is very tricky to say that which one is the 6G technologies, because the technology will be improved continuously from the 5G. And also we intend to introduce, commercialize the new technologies if it's available in 2020s in the 5G system. So so far we don't distinguish the technologies between the 5G and the 6G. So in any case, the 8 topic area from the left top, new network topology, we started to use the millimeter wave in 5G, and we will use the more higher spectrum band to have a more frequency radio resources. But of course, due to the higher propagation loss, we need to consider some kind of a new topology for the radio network. That should be a very low cost and easy to introduce. And the second one is coverage extension, NTN, very important. Yes, as I said, and many people said. And the enhanced URLLC non-public network. Non-public network or private network use will be increased more and more toward the 2030s. So for the enhancement of the URLLC will be needed for the non-public network. And the expanded integration of various wireless technologies, maybe not only the cellular technologies, yeah, such as other access technologies such as satellite, and even for the wireless LAN, NFC, Bluetooth, and so on. Even for the underwater wireless communication should be considered. That those kind of the access wireless technologies should be integrated for the subscribers and the customers. And they're going to right frequency extension and improve the spectrum utilization. And yes, we should challenge to use the much higher spectrum bands, such as terahertz. But considering the difficulty of the device commercialization and availability in the future, our current target is up to 300 gigahertz, not the 1 tera, 2 tera. 300 gigahertz should be a good highest target for the 6G for now. And the further enhanced massive MIMO and wireless technologies, of course, that should be needed. And multifunctional and the AI in mobile network. AI should be used even for the radio and the mobile communication systems more and more. There are some of the technologies has already discussed even in the 3GPP, but maybe we should enhance the utilization of the AI technique for the toward the 5G version and 6G. And finally, advanced and flexible network architecture. Yeah, actually, use cases on for the mobile communication system will be diversing. Yes, there are more use cases will come. If so, maybe we should consider the more flexible network architecture, and also due to the increasing traffic, and also another further requirement on the security and so on. Maybe we should consider the very brand new network architecture to the 6G. Yeah. These are our technical components we are considering now. Yeah, And especially terahertz level, the very high spectrum band should be used, but yeah, due to the much higher propagation loss, it is a little bit tricky to say that the terahertz level spectrum band can be used in the real environment. Of course, we should conduct the trials using such kind of very high spectrum band, but it's a little bit premature. So we developed a so-called 6G real-time simulator. This is simulator, but we can provide a demonstration using this tool. And this tool simulator has a capability for both 5G and the 6G, so that we can compare the performance between the 5G and the 6G. For the 5G case, as you can see the right-hand side small table, we assume the 28 gigahertz band, and the bandwidth is 400 megahertz for 5G. And on the other hand, 6G, we assumed the frequency band, center frequency is 100 gigahertz in a simulator, and the spectrum bandwidth is 8 gigahertz, very wide. And we assume the massive MIMO antenna and a very higher number of antenna elements assumed in a simulator. And we developed two versions of the simulator, shopping mall version and the factory version. And after this, I would like to show the shopping mall version. And I captured the video image of the simulator, so I can show that video. And we will start with the 5G. And in order to have a line of sight conditions, antennas are set on the roof side. And this is a 5G version and 5G situation. And you can see the right bottom square, light blue. This graph shows the ratio of the UE experienced data rate. And oops, sorry for that. And light blue shows the 1 to 10 gigabps. Yes, and for the 5G. And now we are switching to the 6G. Much higher massive MIMO is used. And yeah, left bottom graph is changing, and the red part appears. And the red part means that the over 100 gigabps achieved for each user. And U ratio of the over 100 gigabps is around the 70%. Yes. So according to this simulator, even though the higher propagation loss, this kind of shopping mall condition, we can achieve the very high data rate with even in the 100 gigahertz spectrum bands. Yeah. Okay, this is simulator, but yeah, in near future, we will try to conduct trials in the real environment, and we can verify the actual real performance of the 6G. Okay. Okay, so that's the DOCOMO's views on the 5G evolution and 6G, and also activities. And from here, I'd like to explain the Japanese activities for the beyond 5G 6G research. Yeah, actually, I have two hats. And of course, I'm working for NTT DOCOMO, but also I'm chair of the white paper subcommittee of the B5GPC. This is a Beyond 5G Promotion Consortium in Japan. Yes, I would like to explain the Japanese activities briefly. And this is overviews on the Japan Beyond 5G 6G activities in Japan. And yeah, actually, Japanese government ministry is very aggressive for the Beyond 5G. And upper part show the public-private activities. From the January 2020, and Beyond 5G Promotion Strategy Roundtable organized by MIC, Ministry of Internal Affairs and Communications. And in June 2020, Beyond 5G Promotion Strategy was published by MIC as a discussion of the result of the roundtable. And December 2020, two organizations established. Beyond 5G Promotion Consortium. This was established as an organization to promote the Beyond 5G promotion strategy through industry, academia, government collaboration. And also a Beyond 5G New Business Strategy Center was established to promote IPR acquisition and global standardization related to Beyond 5G strategically. And also private activities also very aggressively done. And yeah, of course, my company is very aggressive. We have already published 5G Evolution 6G white paper in January 2020. Actually, we just published the 4th version of the white paper 2 days ago, yes. And other companies, NEC and KDD, also published the white paper on the Beyond 5G or 6G. And this slide shows the Beyond 5G Promotion Consortium. And this consortium has 2 committees. The one is Committee for Planning and Strategy. And another one is International Committee. And the Committee for Planning and Strategy, this is for the considering the comprehensive strategy for promoting Beyond 5G, creating Beyond 5G white paper. Yeah. And the International Committee is active for the understanding international trend for Beyond 5G promotion, international dissemination of Japan's effort. And of course, this consortium has collaborating with a variety of the organizations, such as a 5GMF, 5G Generation Mobile Communications Promotion Program, and beyond the 5G New Business Strategy Center, and so on. Yeah. And supported by MIC and many organizations. Yeah. Especially, actually, I'm leader of the white paper subcommittees. White paper subcommittees allocated under the Committee for Planning and Strategy. And white paper subcommittee, we have 3 objectives: clarifying the use cases, communication requirement, and the technologies of Beyond 5G, and so on. And creating the Beyond 5G concept that's beneficial to all industries and contributing to strengthen international cooperation. And introducing it globally for international discussions such as ITU. And under the white paper subcommittee, we have 3 groups. First one is the Vision Working Group. This is led by Konishi-san of KDDI, and the sub-leader is Dr. Nagata of NTT Docomo. And this Vision Working Group is creating the vision in 2030, summarizing the use cases and the requirement for Beyond 5G. Actually, we are inviting the variety of the industry people, stakeholders, into this group to provide their future views so that we can capture many variety of industry views into our white paper. Second group is the technology working group, and they are discussing technology trend of Beyond 5G. Yeah, and the third one is ad hoc meeting toward the WP5D. And of course, outcome of the white paper subcommittee should be contributed to WP5D, Beyond 5G program, MT 2030. And this ad hoc group meeting, drafting the contribution for the WP5D based on the discussion result of the white paper subcommittee. Yeah. And this is a very simple schedule of our white paper subcommittee. And by December 2021, we will create the version 0.5 to support the drafting contribution to the ITO WP5D number 40 in February next year. And by March next year, we will publish version 1.0, and this will be open to the public. Yes, and this contents should be captured in the contributions for the workshop on the future IMT vision in WP5D in June. Even after that, we will, of course, update the white paper, and by March 2023, we will publish the version 2.0. Okay, that's my explanation of Docomo's activities and Japanese activities on the Beyond 5G. Thank you very much for your attention.